So the topics which we have started already, how to split the unsymmetrical phasor like voltage and current to its equivalent symmetrical component. Okay, so symmetrical components are positive sequence component, negative sequence component, and zero sequence component. So how can we take decision that it is positive sequence component, or how can we complete the phasor diagram of positive sequence component? How we can draw the positive sequence component? How
It's clockwise, sir.
clockwise?
ABC or clockwise.
ABC will be clockwise sequence, right? So first diagram is the positive sequence component because it is connected in clockwise sequence, and the denoted mark for positive sequence will be 1. Okay, for negative sequence, as it is reverse then positive or opposite, here you can see A and B are connected in anti-clockwise, right?
Yes.
So it is the negative sequence, and the zero sequence, it doesn't have the phase difference, but they all are in same phase, in phase. So this is the zero sequence. So these are the three options. When you split the unsymmetrical phasor, you will get that sequence component. Then operator issue is operator of how we can represent positive sequence component. It is the reference frame or 0-degree angle. So if we want to interrelate that, B will be 240, and 240 can be represented in terms of A square, A operator, because A operator has the value of 120. Okay, that can be denoted by Cartesian domain also. Another thing of complex algebra, actually you have the idea of omega, right? Omega relation.
Yes, omega is 2 pi f, sir. Yes.
Right. Omega actually, omega in terms of complex algebra, right? Omega 1 plus omega square. If you can recall math or something in that course, you may find this relation in terms of omega. But here you have the relation in terms of A. Or if you just make the phasor addition, you will get that result also. But by putting the equivalent value of A and A square, you will get the resultant response like this. So second one is the sequence component in terms of interface, that if it is negative sequence, the 2, it is denoted by 2, is already mentioned from the diagram. You can generate those sequence component, right? Regarding zero sequence, it is the same for all the three phase. Also, the sequence component in terms of what we can say 0, 1, 2 can be added to get the resultant unsymmetrical quantity, right? These are the sequence component aspect. And B, also A, B, C, we already know how to generate that sequence component, and that is based on which theorem? This is the theorem mathematical notation, right?
Yes, sir. We don't know the theorem, sir, exactly, but this was one type of addition.
Based
So
on
the name was with if.
right, Fortescue theorem.
Oh,
right?
Fortescue's theorem, yes, sir.
Fortescue theorem.
Yes.
Fortescue theorem for the unsymmetrical phasor to its equivalent symmetrical component. Okay, Fortescue theorem. So Fortescue theorem is applied to generate those symmetrical component, and these are in terms of, this is in terms of its own sequence component, right? And this is in terms of A. All the sequence components are shifted to A. Initially it was B and C, and now it is all in terms of A. Then after extraction of all the coefficient, we can get the coefficient matrix, which will be A, and this is actually represented in terms of matrix short form. Okay, short form, this ABC, this means ABC is related to 0, 1, 2 in terms of A. Okay, if A has the matrix like this, okay, a transform phasor matrix. And 0, 1, 2 is related to A inverse, right? If ABC is related to A, if you just make inverse, that means this side is reversed, that will A inverse will give the relation in terms of ABC to get the 0, 1, 2 sequence. And we know, or we can find, if it is A, the inverse matrix by 3 by 3 concept, right? Using 3 by 3 matrix, we can get that matrix also. So this is the outcome for 0, 1, 2. Voltage and current can be equally applicable for those Fortescue theorem to generate its symmetrical component. So the third option, or the power option, three-phase power. If we just think of three-phase power can be written like VI conjugate, right? VI conjugate in terms of ABC sequence, and that can be represented in terms of 0, 1, 2. That means this is the sequence component relation. So let's check. Okay. Okay. So if we have different phasor component, okay, phasor components are there. So for phasor component, it is 0, and this is positive, 0, negative. So in this diagram, it is the unbalanced phasor, right? Because they are not connected in 120 different phase degree, right? For phase A, B, C. So if we have been given the voltage in terms of 0, 1, 2, can we find the unbalanced phasor, which is the regular phasor or unbalanced phasor?
So unbalanced one is the 0, 1, 2, right, sir?
Right, 0, 1. No, ABC. ABC is the
Sorry,
unbalanced
ABC.
phasor.
Sorry, my bad. So
ABC,
yes.
Unbalanced phasor, and 0, 1, 2 is the sequence component based on Fortescue theorem. Okay.
Okay. Okay.
So there you have the unbalanced current, sequence component, right? What is given in that scenario? VA0. Try to collect those information. VA0, VA1, and VA2. Okay, these three informations are there in your hand, right? So if you have these three information, try to find the unbalanced phasor, which is VA, VB, VC. Okay, and you will have 5 minutes to do that job. How can you do that? First of all,
Sorry,
Sir,
there was a relation. Okay.
okay, relation, right? First of all, try to collect this information: VA0, VA1, and VA2. Have you taken those information? VA0, VA1, VA2. VA0,
yes, sir.
0.6 90 degree, 1 VA1 1 30 degree, and VA2 0.8 minus 30 degree. Now you have to find the unbalanced phasor. Can you recall the unbalanced phasor equation? That means VA, how they are related in terms of sequence component: 0, VA0, VA1, VA2. And you recall the sequence component relation with the phasor quantity?
Yes, sir.
Try to find that. You will have 5 minutes to complete that information of unbalanced phasor. Let's move to the equation if it is not remembered. Is it necessary to show the equation?
I have it written down, sir. So I'm looking at that.
Okay, if you have written in the last class, you can use that formula. For the time being, can also share that. This is the equation you will require, right? To shift your sequence component to its unbalanced phasor. You have to use these three formula, right?
Yes, sir.
Those formula to generate your unbalanced phasor, which is VA, VB, VC. If you completed the response of VA, try to find VB as well as VC and give that response to chat box. 332. Can you hear me? Three 32. Three 15. Suha.
Yes, sir.
Who is there?
Sir, you called 315.
315, right? 315.
Yeah.
Suha, try to
Yes.
attend that short course which I have mentioned. Okay.
Yes, sir. The short, sir, I joined a bit late. I joined 8 minutes late. Can you explain
Okay.
to me again?
Let me show the screen so that it will be. We are trying to arrange a short course on 26, 27. Okay, and 10 resource person will be there. That will be based on energy system, especially clean energy. That is the renewable energy perspective. Okay, don't miss that opportunity. We have 10 resource person from different institute, and you will learn lots of things from those sessions. Okay. Naushad Amin sir
Yes.
will be there. He's from Malaysia. Abdul Razzaq sir will be there. Alam Hussain sir will be there, as well as Tania Urmi madam will be there. Uh, those are lots of research person and renowned research person. So don't miss that opportunity. Uh,
Okay, sir.
as well as 332 Momo 332. Those who are the regular student, they should not miss that great opportunity. Okay. Uh, 26, 27. Try to make the registration as early as possible because we are running out of time. So if you have not known about that thing, that's why I have mentioned this thing in the class. Omar sir will be there to assist you regarding the registration formality, registration procedure. And you can check also the information related to that in IoT website as well. Okay. So from there you can also get that. And we have opened some short course Facebook ID also. You can also get that from there.
Okay, sir.
332 Momo.
Assalamu alaikum, sir. Sir, roll 332 has said that she has a mic problem.
Mic problem. Okay. Let's make the attendance for short course. Okay. I think he can hear, right, Momo? She has the mic problem, but he can hear. So don't miss. Actually, I am requesting all of you, especially those are very regular, they should not miss. It's a great opportunity to learn lots of things from those resource person in short span of time. And we cannot accumulate those resource person so many times. So it will be a great opportunity. So don't miss that. And for that, the registration procedure is there. So try to do that registration procedure as early as possible. Okay. When you have the renewable energy in the system, what will be there? How can we integrate those renewable, and what are the possible solution, or what will be their drawback or limitation? Those things will be covered in those programs. Okay, So sustainable perspective of renewable, that means topics regarding the net metering will be there, and also the practical or current scenario in terms of Bangladesh as well as the international perspective will be discussed on that occasion. Different direction will be given, so don't miss that. Great opportunity. As well as this program will also give you the clue to have the resource person from other university, so that you can make some collaborative research work or project work in terms of your idea or your perspective. You can also make an interaction session with the resource person. Okay, question answer part will be there, or the discussion you can share with those resource renowned person. So those who have completed the problem which I have mentioned already, let's see whether we have got the response correctly or not. So first answer is VA, which is 1.724 degree phase angle. Okay. Then second one is 0.4 with the 90-degree angle, and third one is 1.7 into 155. So okay, 336 have done correctly. 314 also done the job correctly. Okay. So these are the part regarding the sequence component in terms of voltage and current. Okay. So if we want to move further in terms of impedance, now we will see the impedance scenario, how we can address the impedance scenario. Like voltage and current, you will have the zero sequence, positive sequence, negative sequence impedance as well. Okay. And this is the network which is Y connected network, right? How can we justify that is Y? Is it Y? Can we understand that network of Y? Phase A, phase B, and phase C is there, right? So they are connected in a common point, and that has the neutral connection. Or if you have unbalanced current, in that case, you must have some neutral current, and that will be there. You have also impedance on the neutral path, Zn. Okay. So Zs is the self impedance for the different phase. Here you can see for phase A, phase B, phase C, you have self impedance. Beside that, you have some mutual impedance between different phase, which is Zm. Okay. So if we just want to write KCL for phase A, how can we complete that KCL equation?
Here, IA is equals to IB plus IC.
IA equals IB plus IC.
No, sir. IA plus IB plus IC equals to 0.
Actually 0, right? For this case, it should not
I
be
think
0.
IN. So.
IN, right. IN, because you have some neutral current, right? So it should not be 0. IN. If it is balanced, then in that case, IN will be 0. Okay. And other thing, if we just want to write KVL equation for the phase A, which is VA, can we write that KVL equation?
স্যার নিচে তিনটা লেখা আছে
KVL, can you interpret that equation, or is it okay with you?
Yes sir, it's okay sir.
Regarding
Like
VA?
each phase into their admittance. Sorry, impedance.
Impedance for phase
Current
A,
into,
you can see that phase A has self impedance of Zs, right? But here you can see Zm, because it is due to phase B current, right? Voltage due to phase B current, which is Zm, and that is from phase C. So when we want to write the KVL equation around that loop, these are the source and these are the drop option for the line, right? And IN with ZN. So in this way, we can complete the KVL equation for different phase VA, VB, VC. Be careful about ZS and ZM. ZS is the self impedance and ZM is the mutual impedance between different phase. And Zn is the neutral impedance. Now let's see, yeah, the thing we have already mentioned, IN, which will be the summation of all the three phase. So if we just want to extract, actually when we put that IN in that first equation, what will be the equation pattern?
So one small question, sir. Before that, sir, could you
Yes.
kindly explain the mutual impedance parts?
Mutual, right. Mutual impedance regarding self impedance. When you want to write the voltage expression for phase A, say for example VA, you will have some current, right, for that path IA for
Yes,
phase
sir.
A, and that have the impedance ZS. So IA with ZS, this is for phase A. But you will
Yes, sir.
have some current effect for other phase as well, right? The mutual effect on the phase A due to phase B.
Yes,
What
sir.
is the effect? Phase B has mutual impedance of Zm. So phase B with in phase B effect to phase A, which is IBZm, right?
Okay, sir. Okay, sir.
ICZm for phase C effect to phase A to complete all the current effect for phase A. Okay, that's why it is ZSIA and ZMIB, ZMIC, and ZNIN. This is for last one, this one. So if you just write K VL around that loop,
Okay, sir. Okay, sir.
it will be like that. The regular current is normal, and due to mutual coupling or mutual impedance, you have to consider these two additional part. When you
Sir, one
consider
more question is, sir, for the addition of the voltages, sir,
Right.
using KVL, sir. So
Right.
we have to consider it from the VA terminal to the ground. So that is
VA
why we are
terminal to the-
including ZN. So that is
Right.
why we include.
right, VA to ground, this is the first phase, this is second phase, and this is third phase. Okay,
Yes.
so first phase you have to first, if you don't want to consider mutual, in that case you can write simple equation like IA ZS plus IN ZN, right,
Yes, sir.
using
Yes,
that
sir.
line.
Yes.
But now you have to consider the mutual effect as well in terms of ZM.
Okay, sir.
Okay, that's why
Understood.
ZM and IC you have to consider, IB and IC. In simple way, this part you should not, or you are not generally considering. This part is the additional part, the mutual coupling effect and mutual impedance due to that effect. So when you put that IN in that first equation for VA, what will be the equation pattern? Put that IN there. Okay, then what about the coefficient of IA when you put IN in that equation, VA equation? What will be the coefficient of IA then?
Sir, it's just all the impedances, sir.
Nah, you have to extract the IA coefficient only when you put this IN there, right? When you put IN in the first equation, VA,
Yes, sir.
then
Oh, there's another মানে Z ZN চলে আসে এর সাথে
এখানে
I এর
একটা
সাথে।
আসবে না, you will have IA plus IB plus IC with
Yes, sir.
ZN.
Yes, sir.
So what about the coefficient of IA then?
So that would be
ZS
ZS plus ZN. Yes.
Right, ZS plus ZN, and this is the term, right? ZS plus ZN. Okay. What will be the coefficient of IB?
Sir, same, sir. যেটা দেওয়া আছে that will be added with ZN.
Right, ZM plus ZN. Right,
Yes.
ZM plus ZN. Is it okay for
Yeah.
VA? And this is the matrix form regarding those coefficient extraction. Okay. So VA in terms of IA, IB, IC, all the sequence, all the phasor unbalanced phasors are there in the left side, and phasor currents in the right side. So what about this part? These are the unbalanced voltage, and this is unbalanced current. So this should be, or this must be unbalanced impedance, right?
Yes, sir.
So this will be ZABC. So if we just write that in compact form, that will be VABC, all the phase unbalanced phasor, unbalanced current phasor, voltage phasor are related to unbalanced impedance phasor, ZABC, in a small or compact form. Now this ZABC, regarding that ZABC, we have to shift that to Z012 domain, right? That will be our target. How we can do that? Regarding that shifting, this is the ZABC. That's why I have already mentioned that actually VABC can be written in terms of V012, right? When we shift that VABC, or if we want to just now what you have made the calculation, one problem, right? VABC, how we can relate VABC in terms of V012?
Sir, are you going to repeat করবেন স্যার একটু শুনতে পাই
VABC,
Yes,
we
sir.
want to write the VABC in terms of V012.
A,
Right.
sir.
A multiplied with A, right?
Yes.
A into V012 will give is VABC. So this is the VA012, right? VABC in terms of 012. And ZABC will be there, and this is the part for IABC. Is it okay? When we put the information of VABC and IABC there,
Yes, sir.
right? Then let's move further forward. Now, if we just take a multiplication, a inverse from both the side, this left side A and A inverse will cancel each other. So you will have only A012, and in that part you will have the multiplication factor. Now, in that equation, here you can see this is the 012 sequence of voltage, right? And this is the 012 sequence of current. So what about the remaining part? This part. This will be the zero sequence of impedance, right? 012 sequence, this part.
Yes, sir.
So Z012 will be the total this part. So we know the A operator matrix in terms of small a as well as A inverse, and ZABC is already known to us from that KVL matrix, right? So
Yes,
when we have all the three, that will be something like that.
একটা small question, sir. Sir, এই যে writing VABC and IABC in terms of the symmetrical components we get এই যে এটা স্যার 10.28 পাই স্যার। Sir, এখানে জাস্ট আমরা কি করছি স্যার, মানে A দিয়ে মাল্টিপ্লাই করে দিচ্ছি
No, we have
V012।
put the equivalent information of VABC. This is not the multiplying factor, okay?
Okay.
This is the equivalent of VABC in terms of V012. Only
Alright,
this
sir.
part. And this is the equation. Just now you have solved the problem.
Okay,
The
sir,
problem formulation equation, right? In terms
Yes,
of
sir.
compact form. We have just
Alright.
replaced that VABC in terms of V012 domain, not multiplication A. Because if you
Okay, sir.
multiply that, in that case, Z should be there also, right?
Yes, yes, yes. I
This
understand.
is the replacement. So, so the last part, that means 012, this part is the total part is the 012 part, right? So 012, we know A, we know the value of A inverse and from the last class, as well as ZABC just now from the KVL matrix, right? KVL matrix will form that ZABC. So when we have put all these three, it will something looks like this one. After performing the multiplication for that matrix, you will get that result, okay? But
Sir,
in that result,
আরেকবার থামাই স্যার। এই যে 10.29 এ স্যার ওটাতে যাওয়ার আগে স্যার 10.29 how did our ZABC become Z012?
This one actually you have to check this equation. In that equation, what is the domain of V now? 012, right?
012. Yes, sir.
Instead of ABC.
Yes,
And
sir.
what about the current domain? 012, right?
Yes, sir.
So what about this part? This part, the remaining part is the impedance part, right?
Yes,
This
sir.
impedance part is in terms of also 012. So is the equivalent of 012 impedance.
অটোমেটিক্যালি হয়ে গেল স্যার এটা করতে গিয়ে ABC থেকে 012 তে চলে আসলো।
012, when you shift that in 012 domain, the remaining part, that means ZABC, this total part will be the 012 sequence, right? because
Oh,
voltage and currents are now in 0, 1, 2 domain. So
বুঝতে
this
পেরেছি।
part will be totally 0, 1, 2 domain impedance equivalent.
Okay, okay, I understand.
So when we have all this A inverse ZABC, we will have the this matrix when we put all this information, and after multiplication of that matrix, we will get something like this, the result. Okay, you can do it yourself to justify that whether you can get that or not. Okay, first of all, you have to make the multiplication of this matrix, then you can do that job once again to get that result. 2 times multiplication will be required for generating that matrix. So what will be the last line or outcome of that equation is actually ZS plus 3ZN and ZM. Here you can see ZM, right? The mutual coupling effect. Sometimes you may not need to consider that ZM. Okay, sometimes you will be given the mutual coupling effect and sometimes it is not given. So if it is not there, only the self impedance is there, the equation will be simpler than that. That means ZM part will be 0 if you don't have coupling. Okay, or if you have not given any information regarding that mutual coupling, you will have ZM 0 and the equation becomes simple. Then in that case, the equation will be something like that, right? Only considering ZS, ZM is 0 for this case. So if you have been given or if you are asked to consider mutual coupling impedance, in that case ZM will be there or the value will be there and you have to consider that. Otherwise, you can use that general or simple form. Okay. So Z012 you will have in your hand now, right?
Yes, sir.
Matrix form, this thing you have to remember for the application of problem. Okay, the steps is already mentioned. You have to know the step, but this thing, the result, outcome, you have to remember or memorize. You can say whatever you want to say. This part you have to remember or memorize for 0, 1, 2 sequence. That is the outcome of the derivation. That if you have this matrix, now can you find this is the matrix considering all the sequence component, right? Here you have also 0, 1, 2. So which one is 0 sequence? Which one is positive sequence and which one is negative sequence? Can you identify?
Sir, can you kindly repeat again, sir? Which one
Okay.
is?
First row.
You have 3 parameter, right? The
Yes,
first
sir.
one will be 0 sequence component. Okay, Z0, this part. That means Z0 value will be ZS plus 3ZN. Okay.
Yes, sir.
Z1 will be ZS. Z2 will be ZS as well. So you have 3 different impedance: 0 sequence impedance, positive sequence impedance, and negative sequence impedance. And these are the equivalent value for that. So if you have been given any circuit, say self impedance and neutral impedance is there, you have to generate 0 sequence impedance, positive sequence impedance, and negative sequence impedance. Okay. So they are actually in diagonal matrix, and this position will be considered accordingly. That means first term will be 0, Z0, second term Z1, third term Z2. Okay. All the sequence components are there in this matrix, in the diagonal matrix. So the impedance matrix has non-zero element appearing only in the principal diagonal, and it is a diagonal matrix. Therefore, for a balanced load, the 3 sequence are independent. This is the currents in each phase sequence will produce voltage drops in the same phase. Is very important property. This thing you have to remember. Okay. You can consider that one also. That is the generalized equation, and that is the specific, or when you have Zm is 0. As it is permits the analysis of each sequence networks on a per phase basis. So
Sir, one small question.
Yes.
When we are saying that from the Z0, 1, 2 matrix, we are finding the three values, sir. Z0, Z1, Z2.
That
They are
one,
the balanced load, sir.
balanced load, right?
Yes. Okay, I understand. Yes.
So we have the matrix now in our hand. Okay. So is there any confusion regarding the derivation? That derivation is not required. Okay, but you have to know the step of derivation, what we have done and how we have reached the outcome or result. Okay. The final response you have to remember. The derivation procedure you can have the idea how it is generated, but it's not required for memorization. You
Yes,
know, you have to know how that comes. And this matrix you can cross check. Okay, the Z0, 1, 2, whether you can get that or not. Okay, try to find that by multiplying this matrix, and then you have to multiply second times with that, considering 1/3 of also. So that's the thing you have to do. Okay. Sequence impedance. Okay. So that's all for today. I think so. If you don't have any question, that will be the discussion of today's. Okay. Now, how to generate sequence impedance for Y connected load. Okay.
Yes, sir.
So the steps are there already mentioned, and try to attend the short course which I have mentioned. If you miss some class for one lecture, I think you can manage that by taking their recording session, right? You can collect that recording, or you can perform that recording session later on, so that that can be available to you. So you will get two opportunity by single time. So that's all, I think. If you don't have any question, I want to conclude today's session now. Okay. If you have any question, yes. If you don't have any question, we may conclude. Thank you all.